number 1 to 22.
All right, we talked about this in the first chapter, but it comes up a lot today. Definition of between. It's not my favorite way the book handles this. So, you guys remember this? What does it mean for a point to be between two other points? Okay, well basically it's got to be on a line between the two other points. And if it is, here's how the book writes it. If A, B, C. This means if B is between A and C, here is what we know. Here's what's true. Then the length of AB plus the length of BC should equal the length of AC. This length plus this length equals this length. If B were not between A and C, this length plus this length would not equal this length. But if it is on the line between, that's what we do. So this is called the definition of between. Okay? This means if B is between A and C, AB plus BC. Okay. Say a million times, but we got one more definition. What was it? I need to look it up. It was this is also from chapter 1. I don't know. Yeah, I think I mentioned it in chapter 1. Definition of congruent segments. It's kind of a silly little thing, but we're just kind of practicing giving reasons, and these are some of the reasons. So if two segments are congruent, like segment AB is congruent to segment CD, then what does that mean? Well, it means they're the same length. How do we write they're the same length? We just put AB, without a line symbol, equals CD. Okay. The length, this is referring to some number, a number that describes the length. If those are equal, then the segments are congruent. Congruent just basically means they're the same thing. All right. So those are from chapter 1, but we need them a lot today. Okay. And then from yesterday, probably should take notes on that if you didn't. Might be too late though. From yesterday, we had a couple properties that are going to show up a lot. Well, maybe 3 or 4. One of them is called the reflexive. This is like on the top of page 99. You guys, anybody remember what the reflexive was? Used it a couple times yesterday. It's where you have like A equals A. Like something is equal to itself. So if you're talking about reflexive property of congruent segments, it would be like segment AB, congruent to segment CD, or sorry, it's congruent to itself, AB. That's reflexive property. Symmetric property. I'm going to abbreviate here for time's sake. It says something like, if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. So it just says the same thing backwards. What else do we need from yesterday? Transitive property. I don't know if I'm going to write that one down, but do you guys remember what that one was? It's like if A equals B and B equals C, then A equals C. So it's like they're all connected. So you could do that with congruent segments. If segment AB is congruent to segment CD, and segment CD is congruent to segment EF, and segment AB is congruent to segment EF. Transitive property, substitution will come up today. Substitution. This is more from back from algebra, but this means replace something with something of equal value. Substitution. Replacing something with something of equal value. That comes up at the end though. All right. Got it. These two show up a lot. The first two I did. These two show up quite a bit. Okay. Let's get back to it. Number one, supply the reason that supports the statement. So it's kind of like they said a statement and a proof, and we're supposed to say the reason that justifies the statement. Kind of saying the rule that says this is okay. If A and B are 2 points, okay, the first three questions actually go back to page 12 in chapter 1. You guys remember that page? Mm-hmm. It was like expansion postulate, 3 non-collinear points are in one plane and all that stuff. So you kind of need page 12 to help you with these first three. So the first one says if A and B are 2 points. Okay, are you getting this from page 12 or the back of the book?
Page 12.
You almost said back of the book. All right, if A and B are 2 points and exactly one line contains both A and B, what's that called? Line postulate. Line postulate just says any 2 points are contained by exactly one line. But yeah, that's the line postulate. I don't really expect you to have these memorized. Maybe transitive property, substitution. These are pretty important in the long run. But you can kind of learn them as you go, and I'll warn you before the test. Okay, number 3, given plane P, the plane contains at least 3 points. So which postulate says a plane contains at least 3 non-collinear points?
Expansion postulate.
Yeah, it's expansion postulate. The plane postulate kind of says the same thing but backwards. It like switches the if and then, does the converse thing. But the plane postulate, or the expansion postulate says any plane contains at least 3 points. All right. Now the rest of these are like from today or yesterday or stuff we've talked about recently. Okay, number 5. If RS equals WI, then segment RS is congruent to segment WI. I'm rewriting it real quick. Okay, what's the difference between these two? You guys know? This is saying if the lengths of the 2 segments are equal, the length from RS is the same as the length from WI, then the segments themselves are congruent. Yeah, this was like the second thing I wrote on the top. Definition of congruent segments. Okay, Luke, you got 2 in a row. Making me suspicious.
I'm not going, I'm just,
No, I'm teasing, I know. I think I know. So even if you know this next one, you just need to act ignorant. AB plus BC. Actually, maybe you should so somebody else can answer. AB plus BC equals AC, then ABC. All right, you guys remember what I said this one was? Okay. If segment AB, the length of segment AB plus the length of segment BC equals the length of segment AC, it's one of these. B would have to be right between A and C for this to be true. Yeah, that's what this means. Then B is between A and C. This is the definition of between. It's kind of a weird one. I'm not in love with how they're setting this one up, but other books do it differently. It's okay. We'll settle. segment KL is congruent to segment MN, then what do we know by the definition of congruent segments? If two segments are congruent, then what do we know? We're kind of repeating what we've already done. The lengths are equal. So how do we say the lengths? We just put KL equals MN. The lengths of the segments are equal.
Is that what we put?
Yes. That was 9. Number 11. If RS plus ST equals RT, then what is true by the definition of between? Okay, the two little segments only add up to the big segment when S is between, right between those 2 points. So you can say S is between R and T, or you can just use their notation, which is, they just write it this way. That just means S is between R and T. When they say between, they mean directly between, like on the line. Okay, 13. They're kind of repeating themselves. We're just kind of doing the same steps over here. 13. If segment, all right, Mike, we haven't had this one yet today. If segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then what can we conclude by the transitive property? Congruent to EF, yeah. If the first is the same as the second, and the second is the same as the third, then the first and third must be the same. That's the transitive property. So that's basically what we said right there. The first and the third must be the same, must be congruent because of the transitive property. All right, 15. So on 15 it says use segments AB, segment CD, segment EF to illustrate the property. So the reflexive property. Do you guys remember what I said the reflexive property was? So way back at the beginning, it's just something is equal to itself, like A equals A. So on congruent segments, it's going to look like this. Segment AB is congruent to segment AB. Something equals itself, or something is congruent to itself. Okay. All right, 17, the transitive property with segments. We kind of just did this one, but okay. If the first segment is congruent to the second segment, you guys know what comes next? Transitive. Second is congruent to the third. Probably should put if up here. Then what do we know? Yeah, to repeat in number 13, basically. They just asked it a different way. The first and third must be congruent. Congruent means similar idea to equals. Equals is for numbers, congruent is for things. This means they're the same. All right. Okay. So what they did on 18 through 21 is they kind of cut out part of a proof and then they left a blank for us based on the context clues. We got to figure out what must go in the blank. So on 18, for example, in the first number 1 it says AB equals CD and CD equals EF. Then what do we know by the transitive property? If AB equals CD and CD equals EF, what must be true by the transitive property? All right, you guys can do that on your own. That was an even. Number 19. So on 19, the first line's a blank, but then on line 2 it says FH equals PQ because of the symmetric property. You guys remember what the symmetric property was?
It's the reverse of that.
Yeah. The symmetric property was if A equals B, then B equals A. So if line 2 said FH equals PQ, what must have line 1 said?
HQ.
You got it mixed up. Line 2 said FH equals PQ.
PQ equals PFH.
Right, got it right that time. PQ equals FH must have been what we started with. Just symmetric property just switches the order on the equals. All right, 21, definition of between, again. So line 1 is the given, which we have to figure out what must have been given. Line 2 is what they concluded was JK plus KL equals JL by the definition of between. If JK plus KL equals JL by definition of between, what must they have said right before line 2 to conclude that? Yeah.
The segment JK is congruent to segment KL?
No.
No. Oh wait, I was congruent one. Is that right, number 20?
Maybe. Okay. If JK, this is like the 4th time we've seen definition of between. If JK plus KL equals JL, then what does that mean?
JK plus JL.
No.
J minus
No. Okay, it means K is in the middle. Okay. I don't know how many times I can do that. K is in the middle, so you could just put, you could write K is between J and L. K is between J and L, or you could write JKL. Means K is between J and L. All right. 22. So this is kind of our first geometry proof here. They're not all this tricky. This one's a little bit tricky because here's the thing about proofs. You kind of have to see them a few times. It's kind of like word problems. You see them a few times, then you kind of get an idea how it works. Okay, so the first, it says supply the missing statements, which means fill in the blank. And then it says given AB equals XY. Do you guys see in the picture what they're talking about, AB equals XY? You guys see AB and XY in the picture? Okay. When they say AB equals XY, they're saying the length from A to B is the same as the length from X to Y. Okay, it's not something we would have known. That's something they're telling us is true. And then they say prove, so this is what we're trying to get to, that AX is equal to BY. So if you look at the last line of the proof, that's what it says on the statement, AX equals BY. That's kind of how you know when you're done, is when you've got to that point of showing that those two are equal. Okay, let's stop and think about this for a second. I don't think the other class figured it out, but see if you guys can do it. If AB equals XY, why would that imply that AX equals BY? Kind of have to look at the picture when I'm saying that. If AX equals BY, why would that imply, or sorry, I said that wrong. If AB equals XY, why would that imply that AX equals BY? Any ideas? Well, let's do the proof, see if you can figure it out. Somehow they showed that it was true. Okay, so on statement number 1 it says AB equals XY. How do they know that's true? Okay, yes, it's given is the answer. Line 1, you always start with the given, like stuff that we just know is true, and then you start with your, because you got to start with something. So the statement on line 1 is given. For every proof, that's pretty much, that's all how you start it. Okay. But they also say on line 1, AXB. What does that mean? X is between A and B. And they also said, what was the other one? BY, XBY? Oh yeah, that makes sense. Okay, that means B is between X and Y. How did they know that? Well, they got it from the picture, which is also given to us. So, anyway, you don't have to write this part, this is what they wrote. But they knew that because the picture basically said it. That X is between A and B is between X and Y. Okay, so line 2 is going to ask, so what do we know by the definition of between? If X is between A and B, what do we know?
AX XB equals AB.
Yeah, all right. We got at least one that's starting to get it. AX plus XB equals AB. You kind of have to look at the picture to figure out what that means. If X is directly between A and B, this is the only time this works. The two little segments add up to the big segment. All right. Anyway, and also, similarly, somebody besides James,
Yeah.
which, what would this one turn into? How about somebody besides James and Hank? Maybe an answer. Well, I guess Luke answered something. Corbin, you want to try? Okay, James turned this one into this. So, follow that pattern. I don't think put a point on the book's gonna help.
XB plus BY equals XY.
That's why I was putting it blue,
Why?
because it's on the line,
Hmm?
on the picture, it could help you figure it out.
Oh, well, you can kind of see right here. From A to X plus from X to B equals from A to B. You can just look right there. Anyways, they gave the reason for that definition of between. So, all right, here's where the trick comes in. On line 3, well, they kind of did the trick for us. We gotta say the reason though. AX plus XB equals XB plus BY.
Can you write that down?
No, but I need to point at it, so
Oh.
I need to write it down. How did they figure this out? Okay. The way, kind of, yeah. So on line 1, they said this. Line 2, we said this. On line 3, they said this. How did they get from here to here? Okay. AB, on line 2, we said AB is all this stuff, right? And then XY, on line 2, we said it is equal to all this stuff. Yes. So this kind of goes here, replacing it. This replaces XY, and that's how they got this. You guys follow? This went here, this went here, and then they got this new line. That is called substitution. It is also transitive property. Transitive actually is kind of substitution because it's both. So we're substituting because we're replacing AB with what AB is equal to. And we're replacing XY with what XY is equal to. And getting this new line. Okay, so the reason is, this is the blank part. Substitution. I would accept transitive property also. They're kind of interchangeable. Okay, the next line they give the reason is reflexive property. Do you guys remember what reflexive property was?
It just shows the same answer.
Equal to itself. So this step, yesterday when we did algebra, we kind of skipped this step because they just didn't ask for it. But reflexive property is when you show something equal to itself. So the reason they wrote this is because they're preparing to subtract this value from both sides of the equation. So it's kind of like they're showing their work that they're about to eliminate the xb from both sides of the equation. So if we take xb out of both sides, we're left with line 5, which is ax equals by. But what's that called when you take out the same value from both sides?
Addition.
Right. We're really subtracting, but remember yesterday, they still call it the addition property of equality. Actually, did the book give that answer, or was that our blank? I can't remember which was blank. Is that this part? Okay. I don't know if that made sense to you, but let me try to explain it really briefly. Let's see, this is AXBY, right? Yeah. Okay. So at the beginning, they said this segment is equal to this segment, right? And then they said, therefore, this segment, BY, equals this segment, AX. Why is that true? Because if these two segments are equal and you cut off XB from both of them, then the remainder should be equal. Okay, if these two segments are equal and you cut off XB out of both of them, then what's left over should still be equal. So that's kind of what the proof just said. It's kind of complicated. Not all proofs are this complicated, but yeah, like I said, you kind of have to see these a few times to get the hang of it. Substitution is a very common trick in proofs. So anyways, the end. I will help you as much as I can with proofs. I still will put one on the